Hey everyone, welcome to the part 3 of series Mathematical Tools in Physics. In this video, we are going to discuss differential calculus and integral calculus, which has its uses in physics. So firstly, what is differential coefficient? Let y be a function of x, which is written as y is equal to f of x. Suppose the value of x increases by a small amount delta x. Here del is the symbol of change. Del means change. Then the value of y also increases by a small amount, say del y. So this is x-axis and this is y-axis. Say this point is x1 comma y1 and this point is x2 comma y2. If you have to find the change from this point to this point, then the change in x del x will be x2 minus x1 and change in y will be y2 minus y1. So this del x and del y are the change in coordinates. When this y changes in accordance with x, if x changes by delta x, then y also changes by delta y. Then delta y by delta x is called average rate of change of y with respect to x. When delta x approaches to 0, that means delta x become very small, that it is almost equal to 0, means the change in x is very small. When the change is very small, then the limiting value of delta y by delta x is called differential coefficient or derivative of y with respect to x, and it is denoted by dy by dx. So we can say that dy by dx, that is the derivative of y with respect to x, is used when the change in x becomes very small. So derivation is used for very small changes. So we get the formula dy by dx is equal to limit delta x approaching to 0 delta y by delta x. Physically, the derivative dy by dx gives the instantaneous rate of change of function y with respect to variable x. For example, if we write dx by dt, then this is the instantaneous rate of change of, say, distance with respect to time. Distance upon time is speed. There are some important results of differentiation that are used. First is, if c is a constant, then derivative of c with respect to x is always equal to 0. That means the derivative of a constant is always 0. And then there is derivative of c into y, that means a constant multiplied by variable. So when there is a constant, we write the constant outside the derivation and derivate only the variable, that is dy by dx. Next is derivative of x raised to the power n with respect to x, which is equal to n multiplied by x raised to the power n minus 1. Power is reduced by 1. Then is addition rule. Let y is equal to u plus minus v, where u and v are functions of x. Then dy by dx is equal to du by dx plus minus dv by dx. U and v will be differentiated differently. Product rule. If y is equal to u multiplied by v, where u and v are functions of x, then dy by dx is equal to u multiplied by dv by dx plus v multiplied by du by dx. You will write u as it is and derivate v, plus write v as it is and derivate u. Then is quotient rule. If y is equal to u divided by v, where u and v are the functions of x, then dy by dx is equal to v multiplied by du by dx minus u multiplied by dv by dx upon v square. Then we have chain rule. Let y be a function of u and u be a function of x, then dy by dx is equal to dy by du multiplied by du by dx. Let y is equal to u raised to the power n, for example. Then derivative of u raised to the power n by dx is equal to n multiplied by u raised to the power n minus 1 into du by dx. When you try numericals related to these formulas, you understand them better. Now here are some standard derivatives. Derivative of log x to the base e is equal to 1 by x. E means exponential. Derivative of log x to the base a is equal to 1 by x into log of a to the base e. Derivative of e raised to the power x, that is again an exponential. It is e raised to the power x itself. Derivative of a raised to the power x with respect to x is equal to e raised to the power x and log of a to the base e. Derivative of sin x is equal to cos x. These are also very important. And d by dx of cos x is equal to minus sin x. Then d by dx of tan x is equal to secant square x. D by dx of cot x is equal to minus cosecant square x. D by dx of secant x is equal to secant x into tan x. D by dx of cosecant x is equal to minus cosecant x into cot x. Now let's try a question related to differential calculus. Show that power is the product of force and velocity. We have to prove that power is equal to force multiplied by velocity. For this, we will take the formula of work done. We know that work done is equal to force multiplied by distance. W is work done here and S is the distance and F is force. We also know that power is equal to rate of change of work. That means power is equal to dW by dt. That is the rate of change of work with respect to time. So from this equation, if we put the value of work here, then d of force into distance divided by dt. So which formula will be used here? We would use this formula, that is derivative of a constant multiplied by variable, that is constant into derivative of variable. Since force is constant here, so power is equal to force multiplied by ds by dt, that is the rate of change of distance with respect to time, which is equal to velocity. So power is equal to F multiplied by V. Let's try another question. A particle is moving with a uniform acceleration. Its displacement at any instant t is given by s is equal to 10t plus 4.9 t square. What is the initial velocity? Velocity at t is equal to 3 seconds and the uniform velocity. Let's find this. We are given that s is equal to tan t plus 4.9 t square. To find its velocity, we know that velocity is equal to rate of change of distance or displacement with respect to time. So we will put the value of displacement here and derivate it with respect to time. This will be tan t has power 1 and its power will be 1 minus 1 plus 4.9. Now if we derivate t square, then 2 will come here and t raised to the power will be 2 minus 1. By using the formula d by dx of x raised to the power n is equal to n into x raised to the power n minus 1. So this will be equal to 10 t raised to the power 0 plus 4.9 into 2 will be equal to 9.8 t raised to the power 1. So this can be written as 9.8 t plus 10, which is equation for velocity. We are set to find initial velocity. Initial velocity means velocity at t is equal to 0 when the time is 0. So if we put t is equal to 0, then initial velocity, let us say vi, is equal to 10 meter per second. Then we have to find the velocity at t is equal to 3 seconds. Now velocity is equal to 9.8 t plus 10. So if we put t is equal to 3 seconds, then v when t is equal to 3 is equal to 9.8 into 3 plus 10. So this will be equal to 29.4 plus 10, which is equal to 39.4 meter per second. And then we have to find the uniform acceleration. Uniform acceleration A is given by derivative of v with respect to t. We know that acceleration is change in velocity with time. This is the formula for change in velocity with time. So put the value of velocity here. We know that v is equal to 9.8 t plus 10. Derivative of 9.8 t plus 10 with respect to time. This will be 9.8 because t's power will reduce to 0 and 10 is a constant. Derivative of constant is again 0. So we have 9.8 meter per second square as uniform acceleration. This is the acceleration due to gravity. Now let's try this question. A balloon is filled by air so that its volume V is gradually increasing. Find the rate of increase of volume with radius r when r is equal to 2 units. So we are given the radius of balloon is 2 units. And we have to find the rate of increase of volume with respect to radius r. So for that we must know the formula for volume of sphere. Volume of sphere is equal to 4 by 3 pi r cube. So if you have to find the rate of change of volume with respect to radius, then it will be derivative of v, that is volume, with respect to radius, which is equal to 4 by 3 and pi will be as it is since these are constant, and we will do derivative of r cube with respect to r, which is equal to 4 by 3 pi 3 multiplied by r raised to the power 2. So 3 and 3 will get cancelled and it is equal to 4 pi r square. So if you put the value of r, that is 2, then it will be 4 pi 2 square, that is 16 pi. Let's solve with differential calculus part. Let's now discuss about integral calculus. Integrals are just the opposite of derivatives. In derivatives, you just break a large value into small values. But in integration, you integrate these small values into one value. Integration is the reverse process of differentiation. It is the process of finding a function whose derivative is given. If derivative of f of x with respect to x is f dash x, then integration of f dash x with respect to x is f of x. If you want to understand this formula, when you differentiate x raised to the power n, we get n into x raised to the power n minus 1. But if you integrate x raised to the power n, then its power is increased by 1. Here the power is decreased by 1, but here power is increased by 1, and here we multiply the power and here we divide the power. So this is the main difference in differentiation and integration. D by dx of x is equal to 1, and if you integrate 1, then you get x plus some constant. See here in all the equations is some constant. D by dx of log of x to the base e is 1 by x, and if you integrate 1 by x, then you get log of x to the base e plus c. And similarly, you can learn all these formulas for differentiation and integration. Please do write all these formulas in your notebook and try to understand and learn them. Now let's understand what is definite integral. When an integral is defined between two definite limits a and b, it is said to be a definite integral. It is same as integral, but when you apply limit a to b, a and b are some variables, then it becomes definite integral. Integral of f of x with respect to dx within the limit a and b is equal to phi of x within the limit a to b, then it will be written as phi of b minus phi of a. How it is done? Whatever function you get after integration, you put b at the place of x and a at the place of x and then subtract them. Let's try a question related to integration. This question says that find the value of integration of f with respect to dx from 0 to x, where f is equal to kx. So integration from 0 to x, f of dx can be written as 0 to x into kx dx. Now k is the constant, so it will not be integrated. We have x dx. If you integrate this x with respect to dx, then its power will be increased by 1. Power become 2, and it will also divided by 2, and also it is within the limit 0 to x. So if we put x at the place of x, then we get x square by 2, and if you put 0, we will get 0. So we get x square by 2. K is also there, or we can say 1 by 2 kx square is the answer. Let's try one more question. Now 1 by v dv integration within the limits v1 v2 can be written as log of v to the base e within the limits v1 v2. So it will be equal to log of v2 to the base e minus log of v1 to the base e. Now we have already discussed the logarithmic formulas. Let's recall quotient formula of logarithm that says that log of m divided by n is equal to log of m minus log of n. So from here we get log v2 by v1 as our answer. That's all with the mathematical tools in physics. We have discussed all these topics. If you have any query or you want to try more numericals related to these topics, then please do comment. Also, if you like this video, then please like and subscribe to our channel. Thanks for watching.